Okay, it'd be great if we can start just with a little bit of a brief introduction to Gradient, the company. What is it you do?
Gradient is end-to-end water treatment solutions company. We truly are a different kind of water company in that we have these solutions which completely recycle and reuse highly toxic, highly contaminated wastewaters, the toughest of the tough wastewaters across industries. If you look at our clients, the Fortune 100 companies in semiconductor, in food and beverage, in chemicals, in oil and gas, in renewable energy, and so on. We go into their factories. They all consume everything we use, from our cell phones to our cars to manufacture them consumes a lot of water, and we minimize the amount of water that is withdrawn by closing that loop. So we take the wastewater that is generated from that production, and we produce water which is good enough for the same production. So that's what we do.
Okay, and I guess it's no secret that some of those major water using industries you've referenced there, that there is an ongoing major challenge when it comes to minimizing the water that they use and then clearly optimizing the water they have there in terms. And I guess sustainability is the number one driver. I guess they're in the spotlight for people are looking at them to ensure that they are as efficient as possible. Is that fair to say?
Yes, there is the sustainability angle, and the companies want to be responsible, but it's also a continuity of business issue for them. An example would be if you take, say, TSMC, Taiwan Semiconductor Manufacturing Corporation. Taiwan has the lead market share in producing microchips around the world today. And Taiwan is naturally a water catchment area. They have a lot of water, but because of presence of cutting edge industry, mainly semiconductor manufacturing, they have become water stressed, and hence recycling water is an absolutely vital mandate for TSMC to thrive and grow. And before Gradient, companies like TSMC could recycle maybe 50% of their water. Gradient has made it possible to recycle greater than 95% of their water. And I can give you several such examples.
Okay, yeah. I mean, we'll come on to the semiconductor industry in a moment, but first up, perhaps the data center industry, because again, I know that's everyone knows they consume a lot of power, but it's perhaps less well known that they're also using quite substantial quantities of water.
Hmm.
And then we've got this AI boom, which is probably making the situation. So, how would you sort of characterize the data center industry in terms of its water usage at the moment?
Data centers consume a lot of water because the microchips require a lot of cooling. And whether you use cooling towers and traditional cooling methods, or direct liquid cooling or direct chip cooling and other more cutting edge methods, ultimately the heat sink tends to be water. And ultimately, the way that heat is released into the environment is through evaporation of water. So a tremendous amount of water is consumed by data centers. For example, if you take Stargate, which is being built in the US right now, you are talking tens of millions of liters of water a day. And if you add all this up with all the data centers that are cropping up in the US, in Europe, in the Middle East, in Malaysia, and all over the world, we are talking humongous amounts of water being consumed. I did some math on this. Just LLMs like ChatGPT and the computing power required for them and the data centers that are going to be set up for them by 2028, just the LLMs would consume more water than the entire United Kingdom for all its purposes. So it's a huge problem. Fortunately, there are solutions for this. Water recovery and minimization is quite advanced in terms of technology around the world, Gradient being a leading provider of the same. And one thing I have to give the data center, the big tech who are putting the data centers down, they're conscious of this problem, and they are engaging companies like Gradient to minimize their water footprint.
Yeah, I mean, I believe you're. I mean, I suspect you've got yeah, a big portfolio of clients, but I think at the moment you're working on a couple of data centers, one in the US and one in the Indo-Pacific. I mean, could you just give us a flavor of what it is the technology you provide, how you work alongside the data center operators, to help them optimize, water usage and obviously minimize the amount they actually need in the first place.
Yes, we recycle water. So from data centers consume these millions of liters a day, and some of that is evaporated into the environment, but most of that is just uh, contaminated from one thing or the other, and we are able to recycle it. One of the streams that we recycle is this cooling tower blowdown. As we run cooling towers, over a period of time, you have to blow down some of that water, reject some of that water, because it becomes quite contaminated. And Gradient has the technology to, first of all, up in the cooling towers, provide the right chemicals, provide alternate chemicals, which then enable recycling of the cooling tower blowdown downstream, and we are able to do zero liquid discharge, extract all the water out of that cooling tower blowdown, send it to the front of the data center for use. That thus minimizing the withdrawal from existing rivers and other bodies. Another thing that we do for data centers, because increasingly these come up in arid regions. I mean, they're being built in Arizona and places like those which are quite dry. So what we are able to do is we have technology which is feed water agnostic. So we would take, for example, sewage, and we are able to produce extremely good quality water for data centers to handle. So they no longer need to tap into potable water sources. We also are able to use seawater, any brackish water source like groundwater, which is saline, so that we don't take away from human and agricultural consumption.
And I'm just intrigued as well in terms of the sort of footprint of the technology, because some, depending where the data centers are, obviously, if they're in the middle of sort of built up areas, which quite a lot of them are, is that a challenge for you to install technology, or do you have solutions that can cope with that, as opposed to obviously where you say Arizona, potentially there's a lot of space where you can build stuff. So just, give us some idea of the footprint for your technology.
The water treatment part of our systems are a very small part of the overall footprint of data centers, maybe less than 5% of the footprint of the data center. So that's not a huge problem. These systems are highly modular and multi-staged. So I mean, they're like adult Lego blocks. They are not manufactured at site. We manufacture them at our factories, and we assemble them at site. In some cases, we can start these systems up in a day, of getting to the site, which minimizes the headache for our clients, because our clients are building comprehensive data centers. So by the way, we signed a couple of big projects with data centers just recently, and our clients are building these huge data centers for it. And there are, with these projects, there are constantly issues with timelines and budget. And it turns out we are not in the critical path of that, because we don't take much footprint. We don't need too much time to deliver these. So yeah, I hope that answers your question. I'll give you a quick idea of overall what we offer, if you're okay with me sharing the screen. Is that okay?
Yeah, that's fine. Yeah, we'll do that.
I have a nice picture of what we
Yeah,
offer.
should be able to share now.
This one. Can you see it?
Yep, there we go. Yeah, that's perfect.
So I mean, this is not representative of the footprint. This is just me showing the different pieces of what we offer our data center clients. So this gray thing in the middle is the data center facility, right? And if I can, yeah, pointers, one second, laser pointer, okay. Right here is the data center in the middle. We are feed water agnostic. We take sewage, we take seawater, we take brackish water. We send it to a multi-step modular treatment process. And at very high recovery rates, we are able to produce clean water for the data centers and for the cooling. And the brine that comes out of our system and the blowdown water that comes out of the cooling towers, we further treat for reuse, which goes back into the same loop for data centers and the cooling towers. And we only produce some residual solids from the system. So this way, the water consumption of the data centers is cut by to a tenth of what it normally is, and very little waste is produced.
Think you've already said that in the Taiwan example, there's the water stress is an issue often, and you mentioned Arizona earlier. Obviously, semiconductor industry is that's almost the capital of the semiconductor industry in the States. And again, one imagines water is an issue there. So, just your thoughts, I suppose, as to how the semiconductor industry is addressed. Is it similar to the data center industry, or they need very ultra pure water is very important to them as well. So, are there sort of different challenges in the semiconductor industry as opposed to the data center space?
Um, yeah, I mean there are different challenges. The in terms of the water we deal with in the semiconductor industry, there are two specific challenges. One is because of the various processing that happens in the scheme of producing the microchip, about uh, 12 to 15, 12 to 16 types of wastewaters are produced, and they are a wide range in terms of contaminants. So to deal with that and to treat that and to produce high quality water from that is a huge challenge. And at high recovery rates, for every liter of wastewater, Gradient recycles more than 95% of that. So that's a huge technical challenge, and Gradient doesn't have much competition. There's no apples to apples compared to Gradient for delivering that 95% at a reasonable cost. The other big challenge is the quality of water that is required for semiconductor chip manufacturing. Semiconductor chips, because of Moore's law and how many transistors are being fit into a microchip, require extremely low level of contamination in the water, because the water comes in contact with parts that go into the chip. And if there are too many contaminants, you won't get the precision when you manufacture those nanometer size features on the microchip. So we are talking parts not per billion, not per parts per trillion, but parts per quadrillion level purity. So in an entire swimming pool full of pure water, we are talking one molecule of contamination that is allowed. So it's very, very stringent in terms of what is reusable in chip industry. As opposed to that, in data centers, the quality of water that is required is not so high. But the problem is ever the problem is quite established in semiconductors. Semiconductor chip manufacturing has been around for a while, but as it evolves, of course, the requirements are becoming more stringent. But data centers are new, and people are trying out different ways of cooling these microchips in the data centers. So that is presenting both varying volumetric and contamination levels in what we treat and what we recycle. So that's that's a unique, different part of the problem for data centers. But in terms of water quality, it's less stringent than semiconductor chips.
And in the semiconductor space, I mean, bearing in mind you mentioned the quality, are you able still to achieve high volumes when it comes to recycling and waste, wastewater treatment, etc.? Just, or is that more of a challenge than in the data center space, bearing in mind that the need for this ultra pure water?
No, we are able to get to greater than 95% in the semiconductor space, which is very important because an average size chip foundry consumes maybe 40 million liters a day of water, which is humongous, even more than one data center, right? So it's vital for us to have and if you recycle 95%, what I'm talking about is you only need to bring in 200,000 1 by 20, 2 million liters a day of water instead of 40 million liters. It's a humongous change in the water sustainability. As opposed to if you had 50% recovery, you have to bring in 20 million liters, which, a place like Arizona, some of these locations in which these semiconductor chip foundries are being built it's very difficult. For data centers, it's still a big problem. The the There are set standards and best practices which have evolved over the last 2 decades in the semiconductor industry, which still has yet to happen with data centers. So it's still with these, especially ultra scalers or hyperscalers as they call them. So it's an evolving problem, and we'll see what other challenges it throws up.
Okay, and just in the semiconductor space, I think you fairly recently won a contract to build an ultra pure water facility. I think for a fab in Europe, which obviously these various chips acts, as you know, and there's this sort of reshoring. So I guess it's part of that. And I suspect you might not be able to tell me the client, but just how good is it to win that contract?
It's big for us. We are building, Philip, the ultra pure water, the zero liquid discharge, and the wastewater recycling all together for the largest chip foundry yet in Europe. And we are also building the ultra pure water and the zero liquid discharge for the largest chip foundry in America, in the US now. So we are really the market leader in this space, mainly because of the technology differentiation.
Okay, and in terms of I mean, we've talked obviously about the sort of sustainability imperative, but both data center sector and semiconductors obviously aware of their environmental impact. But I guess there are, I mean, talking the volumes. I mean, clearly they have to pay for the water they use, so I guess there's some significant financial savings. And I know as well that potentially there are also upfront, if you're planning to build a data center in a certain area, whether it's power or water constraints, you might have problem getting planning permission. So just give us some flavor of the, not just the sustainability angle, but the other things that what you're doing helps both in data centers and semiconductors, helps them either, operate more efficiently, save money, or actually get permission to build in the first place, I suppose.
Increasingly, the permission to build and the continuity of business is a big issue. For example, um, just a few years ago, maybe 4 or 5 years ago, Tesla announced that they are building one of their gigafactories in one of the major cities in Germany, and this is not a water scarce place, right? It's a very water rich. There's a ton of water present. So in the press conference, Elon Musk was asked, what about the water? Do you have plans to recycle water? And how are you going to sustainably operate this on a day-to-day basis for years? Won't you consume a lot of water? And he laughed it off. He said, do you, I mean, look around you. This is not Saudi Arabia. There is a lot of water in Munich. I think it was Munich. Lo and behold, 18 months after that, he broke ground on that day. And 18 months after that, he had built his gigafactory, but he didn't get permission to operate the gigafactory because the authorities had calculated he will consume so much water that he would make Munich a water scarce place. Just one gigafactory, because these things consume a lot of water, Philip. So Gradient got involved. We were able to, using our German division, we were able to do water recycling at that facility and get the permits for them to operate. So certainly we help permitting and avoid any business startup or continuity issues for these large technology companies. Another way we help is we minimize the energy and the environmental footprint around water treatment. Even when we are not increasing the recovery rate in some situations, even when uh, we are providing the same level of performance as the other water companies that are out there, we are at a lower energy and a lower environmental footprint, which increasingly for the CEOs of these Fortune 100 companies, how much carbon dioxide they emit is part of their KPIs. So it really gets their attention.
Okay, and I'm just wondering as well. I mean, I was talking to someone the other week, and they pointed out that 70% of the Earth's surface is covered in water. So theoretically, we're not short of water. It's just
Yeah.
clearly desalination is quite an expensive process, etc. I mean, do you think at some stage there will need to be some kind of mind shift to understand that, as opposed to us all saying, we live in water scale. Like I'm in the UK, obviously we have water stressed areas, but we're surrounded by water. We're an island, so theoretically there's no shortage. Just your thoughts, I suppose, as to whether that is likely to happen at some stage, or thanks to the technologies companies like yourself do, can we sort of cope with our existing sort of approach, or will we need to sort of change our mindset at some stage?
No, absolutely. Desalination already powers large regions in the world. For example, the region I live in right now for most of the year, the Middle East, which is, I live in the UAE, in Abu Dhabi near Dubai. But you take Saudi Arabia, for example, 25 to 30 million people, zero rivers. All the water that is consumed by human beings and cattle and agriculture and whatnot, and industry in Saudi Arabia is from the sea. It is desalinated water. Australia has a lot of the water that is consumed there is from their mega seawater desalination plants they built in Sydney and Melbourne and Perth. So, India is another example. China, increasingly, a lot of the water is coming from desalination plants. Where I am from in India, Chennai, essentially ran out of water years ago, and the desalination plants have become a lifeline. Of course, Chennai's water situation improved a little bit over the years, not much, but a little bit. But still, the desalination plants, they are very efficient as opposed to a popular perception because of the evolution of reverse osmosis membrane technology over the last 40 years and energy recovery devices, which have minimized the amount of energy needed to desalinate the seawater. We are at a point where uh, desalination doesn't cost much in terms of so it's increasingly an option for all parts of the world. Yeah.
Okay, and maybe just in finishing, it'd just be good to understand as much as you can share in terms of Gradient's role in that future, how you see your the company developing, whether it's more technology solutions, just getting the message across more. Yeah, just any thoughts you can share as to what's on your roadmap.
We are a possibility partner for our industries. We expand what they can do, where they can do it. For example, Uh, it has always been considered impossible to build some of these larger water-consuming industrial facilities in the Middle East, in UAE, for example, microchip facility, production facilities and such, because it has no water. But because Gradient can recycle 99, 95% of the water within the same factory, and very little is required from outside, like from seawater desal or a river or whatever. Uh, it makes industry possible where it is not, and that's where I see 10 years down the line, 5 years down the line. And the proof is in the pudding. I'm just not painting some head in the clouds kind of scenario. We have grown 2x every year for the last 5 years, and we are the only unicorn in the history of the entire water industry. If you take renewable energy or artificial intelligence, there's a unicorn every month. In the entire history of the water industry, which is centuries old, there has been one unicorn, and that's Gradient. And the reason is we open up industrial possibility for our partners. So that's where I see us going increasingly. We also are increasingly enabling resource recovery. Lithium is required for the renewable energy future, for the clean energy revolution that is happening for the batteries. Because if you want to use renewables, renewables are not available throughout the day, obviously, and hence you need energy storage, and batteries are the best way to do them. And lithium, for example, whether you are using lithium cobalt nickel or lithium ferrous phosphate batteries, lithium is at the heart of these batteries. And lithium traditionally has been mined from hard rock, which is an inefficient process, and it's only available in certain pockets around the world. Australia is where most of the hard rock lithium is available, and most of that is extracted in China. Interestingly, it's mined in Australia and extracted in China, which is not a favorable supply chain situation for anybody, and the costs are very high. So Gradient has enabled producing lithium from brines, from waters like salar brines in Americas, North and South America, and also even from wastewater, oil field wastewater. Recently, we produce battery grade lithium from in Pennsylvania of all places. So we are increasingly into resource recovery. So it's a very exciting company and space to watch. So yeah.
No, it's brilliant. I mean, it's been great to chat to you and fascinating to have your insights into, the data center industry, semiconductors, and just more generally what the possibilities when it comes to water, recycling recovery. So, Prakash, just so grateful for your time. So, thank you very much indeed. Thank you.
No, fantastic questions. Thank you for your interest. It's a very important topic. One of my friends, Philip, is who studied with me at MIT. He became a professor of astrophysics, and he looks for exoplanets, planets which have life beyond Earth. And he tells me that the first signature they look for in an exoplanet is the presence of water. That's how important water is to life,
Yeah.
is that if there is water only, there can be life. So it's a very important topic. I'm glad you're writing about it, interviewing people. Thank you so much.
Thank you again. Thanks.